Hello, and welcome to NearForm Presents. Today we're talking about back-end development with Node.js. So good morning or good afternoon, depending on where in the world you are. And this event is partnered by Prisma and it's hosted by IBM. So it's really great to have you all here. And in a moment, we'll be going over to James to learn about Node.js, apps under pressure. Later on today, we're going to have monitoring your GraphQL API with Fastify, Mercurius, and Prisma. And that will be Daniel Norman from Prisma talking about that. Later on after that, we've got building a full stack framework with Fastify. And Jonas Galvez from HelloPrint will be talking about that. And then we have reactive Node.js finally with Claremont Escoffa and Alex Olikotis from Red Hat. We also have a workshop later today with Matteo Collina. I believe there are still spaces left on that. If you want to get over to the NearForm site, you can register for that. Also on the NearForm event site, you can also see the code of conduct for this event. Without any more to do, I'd like to present James. So James Snell works with me at NearForm, and he's head of research at NearForm and a core contributor to Node.js. He's been responsible for many of the larger contributions to runtime, including the WhatWG URL parser and the initial HTTP2 implementation, adding the web crypto API and more. He's been contributing to open source and open standards for over 20 years now. And he did tell me that I'd trip over that HTTP2 thing, and he was right. So I would like to present James Snell talking about Node.js apps under pressure. Over to you, James.
Thank you, Katie. Hello, all, and thank you for joining us. Definitely want to kick this off. About using Node on the back end. We're talking about one of the most important aspects of it, which really is maintaining the performance. Really keeping a handle on how well your back end Node application is responding to requests. Staying healthy, staying running, that kind of thing. Now, there's one of the tools that we've actually built into Node. It's called the Perfhooks API that allows you to actively monitor how well your Node application is doing, and be able to respond dynamically to if your requests are taking too long, if memory starts to increase, if your Node application is being overworked. This is an API that's built in to Node. You would just require Perfhooks. I'm going to break this down in a few minutes in some examples. But it's there. It's available for all applications to use. And what we want to do here is illustrate a few of the ways in which it's in which it can be used. Let's go ahead and switch on over to show some code. Okay. So the Perfhooks API, it's part of Node. If we go up here and go to the Node documentation, it's been added for a while. But it's one of the ones that is probably one of the least known APIs built into core. Part of it is the performance API, that same that you would see on the browser side. So you have performance.now, performance mark, performance measure. But there's some other things that are in here. There is event loop utilization. What event loop utilization is it monitors how busy your event loop actually is. So how much work is your node process actually doing? There's another one in here called Timerify. And this is one of my favorite ones. You can take any function, wrap it with Timerify, such that it will monitor and actively record exactly how long that function is taking to execute. And there's a couple of ways of getting to that data, and I'll point out one of the more useful ways this thing becomes interesting. One of the other tools in here is Event Loop Monitor, or monitor event loop delay. What this is telling you is approximately how much you are blocking your event loop from being able to turn. So if you have a lot of synchronous processing, if your requests coming to the server, if they're complex, and there's a lot of compute that needs to happen, you're going to be blocking that event loop for a period of time. the longer you block your event loop, the fewer requests you're able to tackle at any given time, the worse your performance of your server is going to be. So monitor event loop delay is what you're going to use to keep track of that. There's one of the more useful utility classes that are in Perfux is the histogram, and we're going to see how this is used here in just a bit. Now, if you are using Fastify, if you are using any of these server-side frameworks, and one of the things that we tell folks as a best practice that they should always do is implement what's called a circuit breaker. Essentially, what the circuit breaker is as the traffic to your server increases, the response, the responsiveness of your server is going to decrease. Makes sense. The more requests that it gets, the busier it's going to be, the less it can respond to other new incoming requests. What the circuit breaker does is once that activity reaches a particular threshold, the circuit breaker will trip, and your application will start automatically sending error responses saying, "Wait, I'm too busy. I need to take other requests I already have." And that allows kind of the routing infrastructure to maybe route requests to a new server, to a new instance. You can use it as a auto scaling queue. But as it goes up, right, as the load on that server increases, you want that circuit to trip. And then as it starts to clear out the activity, once it's done servicing those existing requests, the pressure will drop, and your application will start responding to those requests again. If you're using Fastify, the under pressure module is exactly the additional plugin that you want to use. And what it implements the circuit breaker pattern for you. You plug it in. You register the under pressure module. You set some configuration steps to it, and from that point forward, that server application will automatically be responding to those those pressure events for you. Now, what's interesting about under pressure is it's using all of the mechanisms I'm going to talk about today. So the event loop delay, the event loop utilization. It's also looking at memory consumption on the server to do this. But let's look into the actual APIs and see how those are working. All right. So here we're looking at just some code, very simple node code here. I'm using code spaces to show you this, which is fun. So in this example, we're going to create a Fastify server, right? And basically what this is going to do is simulate some synchronous blocking activity. Right? So we just have a for loop to busy loop the application. And the piece that I want you to pay attention to in this example is this monitor event loop delay. We're importing it from Perfux, right? We're going to create a monitor event loop delay, and then we're going to enable that. What is happening here is Node, when you set up monitor event loop delay, internally it creates a timer. Or not really a timer. It's a check on the event loop that runs every time the event loop turns. The busier that your event loop is, right, the longer between runs of that check is going to occur. So if your event loop is idle, if it's not doing much but it's constantly turning, right, the length of time between those checks is going to be very short. If your event loop is busy, if you're serving lots of requests, if you're doing lots of synchronous blocking, the length of time between those check runs is going to be longer. And all the monitor event loop does is measure the time between those checks and records it in a histogram. So every time it runs, just record. What you can do is turn around and monitor that. The longer that gap gets, the more your application is being blocked from turning over doing the next thing. So when you enable that, that's all it's doing. It's just installing that check. And then from there, what we can do is actively monitor. Here, we're doing it for every single request. We're going to output the mean gap time, and we're going to put out output the max gap time, right? And then we're going to go ahead and do it. Now I'm using a couple of tools here. There's this one called Notari, which is a very rudimentary kind of performance observer you're meant to run in the console. All right, so I'm going to put this up in one. We're going to come over to where we have event loop delay, and I'm going to go ahead and start my server here. If I just node examples, event loop delay index.js, you can see that Notari is starting to respond. And essentially, I'm going to let it just sit for a second and baseline the event loop delay. What we can see here is typically just with an idle server, you can see that the event loop delay is pretty minimal. These numbers are in nanoseconds. All right, let's go ahead and throw some load. And for that, we're going to use AutoCannon, which is a benchmarking tool. Okay, so as we see here, we're seeing the monitor, the mean wait time. We're seeing the maximum wait times, right? And what we see here on Notari is we see the event loop delay has increased significantly, right? And it's able to track where that event loop delay is happening in real time, right? So we see the max, we can see the minimum. The minimum event loop delay here is going to be the sampling resolution. The monitor event loop delay has kind of a minimum sampling rate that it follows. Whatever you set that minimal sampling rate is what the event loop delay is going to, the minimum is always going to be. All right, so here what we want to do is pay attention to the upper end. We want to see the maximum event loop delay, and then we want to see the mean. The fact that we can capture this information and output it while the application is running means that we can use this information to actively respond while the application is operating to the slowdowns, speed ups, and whatever we where we want as that application is running. So the under pressure plugin will use this as the trigger. It will use this as the trigger to say, well, the server is too busy. If the event loop delay goes too high, goes past a particular threshold, right? In other cases, it may come down to, you might set a very high threshold depending on how it, whatever the target load on a particular server is, right? In general, with the event loop delay, the lower the number, the better. You do not want that number to go too high, just as a general rule. All right, so let's look at another one of them, event loop utilization. Event loop utilization is a measure of how busy your event loop is. It measures, it's similar to tracking the CPU utilization on your system, except that it's specific to this one node process. In this one event loop, it's much more accurate than CPU because you don't have any of the noise from all the other applications that are running, any of the other things that are using that CPU on your system, and it tells you exactly just how busy that node process is. Now, the lower the number, it's generally between 0 to 1, 0 to 100%. The lower the number, the less activity that is actually happening. What you want is to try to find a balance to where you have the highest event loop utilization for the best response rates. And I want to show a bit how this comes together. All right, so let's look at this in this particular example. We're creating our FastDevice server. And what we're doing is we are going to generate a prime number. This is a new API that was added to Node recently for just generating prime numbers. We want it to be 1024 bits long. And we're going to do this synchronously at first. So for every request, we generate the prime number, and then we serialize that as hex. All right, let me go ahead and run this server. All right, and we're going to let our event loop utilization normalize here for just a second. And what you'll find is that the typical event loop utilization for an idle node process, depending on your system, is going to usually be between 0.07 and 0.1, right around in there. So here on this particular server on code basis, we're normalizing the event loop utilization around 0.8. All right, so let's see what happens when we actually run this code. Again, so we're generating prime numbers synchronously. What we see immediately is that event loop utilization starts to increase. We're throwing server requests at it. We're going up to top out of 0.28. Okay, so that means we still have quite a bit of capacity. There's still a lot more that event loop could have done. So let's throw a little bit more load on it. Using AutoCanyon, I'm going to say 100 concurrent requests. I'm going to pipeline, use HTTP pipelining for 10 at a time. And let's throw that load at the server. It's going to take just a little while longer for the event loop utilization to update here. Let's see. There is a little bit of lag time with the code space, so I might need to restart this. 1 second. Normalize it again. Let's load that up. The busier you have your server, the less responsive Natar becomes here. Well, what we see here is that the event loop utilization does start to increase. We can see this with the histogram. We get a up to this 95. That's 95%. What we see is right around the 99th percentile. The event loop utilization is about 75%. So we see with this synchronous block, the event loop utilization doesn't goes up quite a bit. What if we switched to a asynchronous version of generate prime now? Or the generate prime sync, this is synchronously blocking the current event loop. On the asynchronous version, we're actually generating the prime number in a separate thread off the main event loop. So if we ran this code, the event loop should actually be less busy overall, right? Because most of the work is actually occurring in another thread. So let's go ahead and let our utilization here normalize again. We're going to switch back to doing just the default number of connections. And let's see what happens here. So it's the same number of requests going to the server from AutoCanyon. All we've done is switched to using the asynchronous generate prime. We're basically moving work off the main event loop. And what we see is the event loop utilization was much lower. So with the synchronous version, it was about just under 30%. With the asynchronous version of generate prime, it drops down to about 13-14% event loop utilization. So we're taking that work and we're offloading it. We're moving it off the event loop. So the event loop itself is not as busy. With it being not as busy, it means it's able to respond to more requests, and we're able to see more activity happening on that server. There's a greater capacity for it to do more work. So that's the event loop utilization. Between the two, event loop delay and event loop utilization, neither one is more important than the other. They are both very important. You have to have those low delay, and you need to have maximize your event loop utilization. Find the right balance for whatever the performance target goal is for your application. Like event loop delay, the utilization is something you can monitor at runtime, like what the under pressure module is doing, and use it to respond dynamically to what's happening in your application. Now, a couple of the other tools that we have available, one of which is Timerify histogram. Again, what this does is Timerify takes any function, wraps it up, outputs a timer for it. When you do that, you can give it a histogram, you can give the Timerify function a histogram, so that every time that function is run, it'll update the histogram with the runtime of that operation, the execution time. If that could be a synchronous function or it can be an async function. If it's an async function, the histogram will be updated with the time that it takes to resolve or fulfill the promise. So In this particular case, I'm generating the prime numbers in a promise, and then and then seeing how long that's going to take to run. All right, so let's go ahead and just do this as the async version. Right, and we don't need Natari for this. We just want to run. I can run here. Okay, let's go timerify histogram. And if we want to run this, what we see is that we are getting the run times. We'll get the mean runtime execution time for the function. So the mean is, this is how long it's typically taking to run. We'll get the minimum length of time that this function is taking to run, and then we get the maximum time it's taking. And really what you want to do is find the right balance there. Pay the most attention to the mean, because typically that's how expensive, and all these numbers are again in nanoseconds. That's generally, how expensive running that function is in your in your code. The histogram allows you to monitor this at runtime. If you have a particularly performance sensitive function, then what you need to do here is wrap it, run it. It adds very little performance overhead, the actual monitoring. And then you can check that histogram dynamically as your application is running, and respond accordingly, similar to the circuit breaker. So as if a particularly large complex request comes in and it increases the runtime of your function, if there is some set of arguments that make that function run longer than others, right? If as you're going through and working on your code and you have it running in CI, you can look at these things and say, okay, well, this change made the average runtime increase by 30%. These are all things that you can use this timerify for dynamically responding to the performance change in your application. Now, of course, one of the other things that we have in here is the standard performance API that you see on the web platform side. So performance.now, performance.mark, measure, and performance observer. This is there too, and what it allows you to do is have more fine-grained control over exactly what you want to measure. So timerify is just wraps the entire function, right? With performance mark and measure, right? You put the start mark, you can put the end mark and the measure anywhere in the code that you want to measure the amount of time it takes to run code across a particular span. So in here, I create the performance mark. When we start the request, then that's A, right? And then when the promise is resolved, I'll do a second mark, which is B. That's marking those points in the timeline. And then at the end, when the request is being settled, we have the performance measure from A to B, and then I say, give it the marks A to B in the timeline. Then we have the performance observer that is running, that is listening for those measure events, using a histogram to record the duration converted to nanoseconds, and then we are outputting the mean amount of time, the mean, min, and maximum amount of time it's taking for these things to run. These are all things that you can enable at runtime. There is very little performance hit, so you can enable these in production code and actively respond to these. Use these outputs to alter the way that your application is running. So if you want to do the circuit breaker, there's other things you might want to do. Trigger an alert, or just log it. You might have differences of service level agreements, from one different customers, right? These can help you know whether you're actually meeting those service level agreements. So these APIs, they're there. They're all available. You want to look at the perf hooks module in Node. And make sure you go take a look at the documentation. And that's it. I hope it was useful and helpful for everyone.
Brilliant. Thank you so much, James. That was excellent. Now, I know we haven't got a Q&A on at the moment, but if somebody wants to reach out to you with specific questions, can they contact you via Twitter?
Oh, absolutely. Absolutely. Happy to answer any questions there.
Brilliant. Thanks very much. Right. So now instructions on how to move on to the next talk. So you need to go over to the developer, ibm.com site. And if you look under conferences, then NearForm Presents Backend Development with Node.js, you'll be able to see the agenda for today. If you click on the next speaker, you'll be able to see a link through from that will link you to the next page that you need to join. So there'll be no more talks on this particular web URL. You need to move to the next one. So I'm heading over there now, and I hope to see you there too. All right, cheers. Bye-bye.